So here they say the diagram represents the pattern of waves with a frequency of 30 hertz moving from the left to the right. All right. So now we already know the frequency of these waves. That's fine. Now, if we look at this diagram, we can see that we actually have two complete waves. Because if you look at from R all the way to T, it's one full wave. And then from T all the way to this point, it's another complete wave. So we have two of them. Now, furthermore, they tell us that the distance between these two successive troughs is given to us as 4 meters. And we know that these two troughs are exactly in phase, which means the 4 meters is actually the wavelength. So meaning the distance B is also going to be 4. That is wavelength. The distance between two successive points that are exactly in phase. That's fine. Now let's talk. The first question says, define the term transverse wave. Well, you now know how to define a transverse wave. So we can pass it as though we don't see it. The next one says, label the points A, B, C, and no, just A, B, C. In other words, tell us what is the names of the points A, B, and C. Well, if you look at point A, it's the lowest point on this wave, so it becomes a trough. All right. If we look at the point B, B is not a point, but it's a distance between two crests. So B becomes the wavelength. And then C is the highest point on the wave. So it becomes a crest. All right. Trough, wavelength, crest. Those are the labels. Then listen to the third one. This one says, how much time has lapsed while the wave moved from R to T? In other words, calculate the time taken for this wave to move from the point R to the point T. And what is from R to T? Well, it's just one full wave. So in other words, what they're saying is calculate the period of this wave. Because I told you that the period is the time taken to complete one cycle, or the time taken for a complete wave to move past a fixed point. Now, since we know in the statement, they already gave us the frequency, and we know that the frequency and the period, they relate according to this formula. But of course, you could have decided to go straight to the formula for the period and say period is equal to 1 divided by the frequency. Then you say the frequency is 30 hertz. So if you go to your very nice calculator and say 1 divided by 30, well, you simply get 0.03 seconds. Because in physical science, we always take our answers to 2 decimal places. So that's the time taken to complete one wave. Now, the next question says, are points R and S on the wave in phase? And please explain your answer. Why do you say those 2 points are actually in phase? So let's look at those 2 points. Well, this is the point R and this is the point S. Now, are these 2 points in phase? No, they are not in phase. Why? Well, remember when we defined the points in phase, we said they have to be moving at the same time, they have to be moving at the same speed, in the same direction, right? But that definition is not enough in terms of answering why is R and S not in phase. Now, this is what you will say. Well, you have to tell them that in order for 2 points to be in phase, they have to be separated by a complete number of wavelengths. Or you can say R and S are not separated by a wavelength. In other words, they have to be separated by a distance of 4 meters in order for them to be in phase, which is why the point R and T are in phase, because the distance from R to T is 4 meters. So that's the reason. In order for them to be in phase, they have to be separated by a complete number of wavelengths. Right. And then what about the next question? Well, the last one says, please calculate the speed of the wave. And we know that in order to calculate the speed, that's if we know the wavelength as well as the frequency. And in this case, we know both of them. The wavelength is 4, the frequency was given to us. Well, this is the formula we use for the speed. We say speed is equal to frequency multiplied by the wavelength. All right. Then we come and say, well, the frequency is given to us as 30 hertz and the wavelength as 4 meters. So 3 by 4 is 12. So the speed of this wave will simply be 12 meters per second. Over and out.